Now you see, I've just done this and my screen capture program has lost a lot. So my sense of humour is running thin again. And I had lots of really good jokes, and it was great. And there was a song at the end, and Kylie Minogue came in and duetted with me, but she's gone now, and I can't do any of it again. And it's all got lost, and I hate this program. And this is the second time it's done it. And if it does it again, you may never hear from me again. But in the meantime, we still have to do it. So writing games with C# and XNA must stay on the road. I'm getting nervous though now because I'm not quite sure what to do and why it doesn't work. It's a big worry. It's still going. Is it still going? I can't tell. Anyway, button bash is what we're doing. We're counting button presses. It's no use crying over spilt milk or cheese. Or actually, spilt milk becomes cheese after a long period of time. We just get on and we do it again because we're professionals. We're tough, rough, and anything else that finishes off that sentence nicely. So we're going to make a game, actually quite a good game. It's a game that's actually been out there for a while. We know about XNA games, we know how they fit together, we know that they have the C# code, we have these methods, one called draw and one called update, which do all the work, and one called load content that fetches the sprite, the actual fonts and things. We can read user input, we can scan the gamepad, we can do all that good stuff, and we can display text on the screen under the control of our program. So now we're going to make our first proper game. Okay, and it turns out that this actually game is going to be called Button Bash. Now there have been games like this out there for a very long time, and what their basis is effectively see how many times the player can press a button in a certain amount of time. Lots of sports simulation games, Olympic running games, all kinds of good stuff like this rely on this very simple technique. So the idea here is that we're timing how many times a player can press a button in 10 seconds, and then the more presses they get in, the better the game. Okay, now that means that the first thing we do when we're writing a program like this is try and think, okay, what is the data we have to store and how we're going to store it. We need a counter called presses, which is an integer, and we set that to 0 because when we start the game there are no presses. Okay, and so what we have here is a variable called presses, and it's presently set to 0. And now I've added a variable to hold that, and so the idea is that each time our program detects a button press, we increase the counter. The declaration sets the value to 0 so that we start counting at 0. And I did this much better last time. But you'll never hear that, I'll never hear that, no one will ever hear that, but I'm not bitter, I'm moving forwards. Okay, so we have our presses variable. We have a thing called drawString we've used before. We used it to draw messages on the screen, and we can feed these things with a string, which in this case is the word presses, followed by a string version of the variable which holds the number of presses we've got. So toString is a way of saying to presses, hey, give me a string version of yourself, and it goes off and does that. So whatever numbers in presses comes back as a string, because we can print strings. We know how to put things on the screen which are strings. So we take the value out of presses, make it into a string, add it on the end of the word presses, draw it on the screen at a particular position, and use the color white, and we're in business. Okay, that's how we do it. Right, so that's what we do, and the update method we want to make, well, this looks reasonable. Get the state of the gamepad, yes, for player 1. Get the state of the button A, and if it's pressed, increase the presses counter. Okay, it is as simple as that. Okay, so if the button has been pressed, make the counter 1 bigger. And that looks like it might work okay, so we'll make a game based on it. So I'll just go off and let's see if we can make this go. And I'm going to get rid of that one because that one does work. I'm going to go onto my desktop, which is here, and I'm going to open up demo 1, and I'm going to fire up this program, and I'm going to show you the code. Show you the code! Okay, there it is. Oh, my recording stopped. I think, I don't know, it's hard to tell. I digress. So this is my program. This is my test. If A is pressed, make presses 1 bigger. Okay, and gamepad 1 is the gamepad I'm using. So I run this program, and there's a rattling noise, and the program starts going. Bum, ba, dum, ba, dum, ba, dum, bum. And if I get my gamepad, having just whacked my headphones, I didn't do that last time either, but I digress. There's my value presses, which is presently 0. If I press down the green button, which is button A, then whoa, I'm good. My heavens, I'm good. Look at the way that counts up. Unfortunately, if you can hear what I'm doing, button is up, nothing happening, button goes down, whoa, it counts at speed. This is not right, this is not what we want. There is a bug in my program. I want to count button presses when all this thing seems to be doing is counting whenever the button is actually held down. Not good. So I'll stop that program from running. There you go, go away. And I'll drop out of this because it's obviously broken. And I'll get rid of that there, and we're back on this screen. It might not work. Indeed it did not. We're debugging again. We're back in our trench coat with our magnifying glass and our hat, and I haven't got a ponytail, but they do look quite fetching, don't they? Anyway, I digress. We want to look at what's happening and try to work out why, and the question we've got to try and answer is, what will cause the counter to keep counting? Why does it keep on counting up? Why does it only not count when the button is pressed? Well, we know that update is called for us by XNA 60 times a second. So each time the method's called, it will decide that the A button is down, and it will increase the value of presses by 1. Actually, this isn't terribly surprising. If you think back to what we did with our mood light, then we've got exactly the same code in here. And if you held down the button on the mood light, then yes, it did get continuously brighter. So we've actually taken our mood light program and our button bash game and put the two together and found that actually the behavior isn't quite what we want. We don't want the counter to get bigger when the button is down. We want to get the counter to increase when the button is pressed. That's different. Okay? The program must detect an edge, not a level. Okay? All keyboards work like this. When I press a key on the keyboard, or indeed a button on my mouse, or a button on my remote control, or indeed any kind of button that controls anything electronic, from car alarm remotes to anything else, then what the hardware inside is looking for is edges, not levels. Okay? So we've got to write some software that will detect an edge, that will detect a transition from it used to be high but now it's low, the button used to be up but now it's pressed. Okay, that's when the counter needs to increase. If I draw this up in a rather nice diagram, if I do say so myself, then here's the button, chugga 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 chugga. At this point it's pressed and goes down again, and time keeps moving on. If update's called here and it sees the button up, and then after 60th of a second update's called again and the button is now found to be down, then in between those two we must have had this edge we're looking for. So the second time that update is called, if it sees the status change from up to down, it knows the edge has been hit, and that actually means we have to increase our counter. That's how it's going to work. Okay, the key to detecting edges in programming terms, and this is how it works, is to remember the previous state of the button. If the button was up and now it's down, we've had a change since last time update was called, and that's a proper button press. Okay, level is good for things where you want to increase things over time, so making things get brighter when the button's held down. Previous code works great for that. But in this situation, what we want to do is detect the point at which the button changes from up to down. That's an edge. Okay, because update's called 60 times a second, if I make lots and lots of changes in between two calls of update, I won't see them. Okay, because I only test the thing at these regular intervals. And so if Superman was playing and he could press the button up and down in a millionth of a second, then as far as my computer is concerned, my game is concerned, I wouldn't see that, because the first call of update would see it as the button as being up, and then the second call would see it as being up again. If in the middle Superman had pressed it several thousand times, they wouldn't count. That means that anyone that claims that they can press a button up and down more than 60 times a second is lying, because there's absolutely no way that our software or any XNA game software could easily detect that. Okay, so rapid changes can't detect. Fortunately, you can't do that. Mechanically, you can't do that, and so we're okay with this. All right. So First thing I have to do is bang in to my program in amongst the font, the draw position and the actual press counter a variable that remembers the state of the game from last time. Okay, and this actually is set at the end of update to remember how it was last time we looked. Very first time the program runs, we get an empty value put in there, which is basically all the buttons up, nothing much happening, and then we start using that to remember what it was like last time we looked. Okay, now the algorithm we're going to use is a bit like this, and a trick to actually solving problems is to think about things from what do you do to solve it, and then take that description and convert it into a program. I'm thinking about my clip art as being a bit like sort of dance steps that tell you how to do something, but probably a recipe is a better idea. A sequence of steps, a bunch of things you have to do to actually make the problem fixed. Okay, and for detecting edges, if you write it in English, if the previous state of the button is up and the current state of the button is down, then the counter must be increased. If the button used to be up and now it's down, then we have an edge, and then the player has pressed the button and the counter must get one bigger. So the first thing we must do is take this algorithm and make it into C#. And this is what the code looks like to do that. Again, nothing we haven't seen before, just in a slightly different sequence. Get the state of my gamepad. If A is pressed and in old gamepad state A is released, then hey, we've got an edge, make the counter one bigger, and then record the game state for next time round. This little bit here is very important. Miss that out and your game won't count properly at all. Okay, so if it used to be released and it's now pressed, then we have an edge, and it really is as simple as that. And if I drift back to my desktop and open my second demo, here we go, and take a look at the code. Here we are. Get the state, if the button, and this ampersand, which I'm highlighting, is a cunning way in C#. Is a cunning way in C#, I hope that's recorded all right, that allows me to actually combine two tests. Right. And if that ampersand is there, it means condition on one side, condition on other side. If they're both true, I'm true, away we go. So run the program now. Get my gamepad off the floor and press down A. I get one press. Press and release A. So if I press it really fast, it's surprising how tiring this gets. And I can get reasonable speed. But if I hold the button down, it doesn't count up, because it's seeing that last time it was down and this time it's down. Release it, press it again, and at some point during that action it went, last time it was up, this time it's down, time to make the counter one bigger. So we have solved the problem. It all works. Isn't that wonderful? Okay, so drift back to my presentation and notice that we've actually solved the problem. So what we know is that XNA calls update and draw this 60 times a second. A game can detect changes in inputs, edges if you like. Gardeners use hedge detectors, you know. Now it wasn't funny last time I said it either, but I still quite like it. A game can detect edges or changes in inputs by storing the previous state and comparing it with the latest one. And to do that you have to have this extra variable which you have to look after, which keeps the state that it used to be. Okay, and here we go. True or false? 3 this time. An edge is produced when a button on a gamepad is released. That's a very interesting observation. When the gamepad state changes from high to low, the button goes from up to down, we get an edge. If you think about it, we get a second edge when the gamepad goes from low to high. So when the player releases the button, there is a point where one update is called with the gamepad state as down, and the next update is called with the gamepad state as up. We're not detecting that. Our game could. It would make the counter go twice as fast, which the player might quite like, I'm not sure. But that means I think that will go green, and it does. Wonderful. Point 2. If a button is pressed and released in the 6th of a second, it will not be detected. This goes back to Superman and his millionth of a second presses. I reckon that's true because you can't. You haven't got the resolution. This is actually exactly the same as sampling in CD players. CD players sample music. MP3 players, same thing. They sample the sound signal, which is about 32,000 times a second or so, or maybe more than that. I think it's about, and the idea is that if you have a frequency that's so high it goes up and down in between those two samples, you won't hear it. So this is a fundamental principle by which digital things work, and what that means is, as far as we're concerned, our sampling frequency of 60 Hertz means we can't see button presses that happen quicker than that, and that means it goes green. Amazing. Okay, are we going to get 3 greens in a row? Who knows? You can combine expressions using the ampersand operator. This is the AND operator, which is used to say if A and B. The answer is you can do this. It's the 3rd green in a row. Huge cheers. Dancing in the streets. Who knows? 3 greens. Very nice. Okay, so here's the situation where we are now. The button bash game has become massively popular and has now been made into an Olympic sport. Okay, but the people in charge of the Olympics have decided that it's difficult to time people to the required precision by using a stopwatch and a man that shouts "stop" at the end. You see, and people that go on after he said stop cheat a bit and get higher scores. So we want a program that will actually automatically count button bashes for 10 seconds and then stop. Your company's been hired to write this software for the Olympic Games. It's an amazing honour, and so your team has started off. They want a program that will count the number of button presses entered in over a 10-second time period. Unfortunately, the developer who was going to write this code was all set to go when a helium balloon fell on him, and he's now in hospital. I wonder if his voice went all high-pitched as well, but that isn't explained. As far as you're concerned, problem is you must now take over from this developer and finish off the code. If you want to take this challenge, and who doesn't, you can find all the source code and screencasts and everything else on verysillygames.com/screencasts. For more of this stuff, keep coming back, same place. My name's Rob Wiles. It's the 2nd time I've said goodbye, but the first time you've heard it, and I'll be around later. So bye bye for now.